insights for planning and decision making. As an urbanist myself, I'm excited to hear about this. Please join me in welcoming Haozhuo Yang, co-founder of TangibleEmpact and BAC Adjunct faculty member. Take it away.
Thank you so much, Sarah. Hello, everybody. Very excited to be here and just sharing some of the works I've been doing for the past couple of years. So as Sarah said, I am the co-founder of TangibleEmpact, and I'm also teaching the RQ Studio right now in the spring semester. A bit more context about myself. I am a trained architect. I did my master in urban design, but I always have this head of technology on my head. I just very interested in using innovation and technologies to solve problems in cities. And I've worked in a lot of different institutions from both the public and the private side. So I think today I just want to share a lot of endeavors that I've been trying to do for the past 2 years, whether that's from the entrepreneurship or from research, from community building, event hosting, or even from pedagogy perspective. So just to show like as a kind of, I still see myself as a young designer, like how am I approaching AI and these emerging technologies and how that can benefit of our design profession. So first I'll talk about TangibleEmpact. Before anything, I want to echo the point that raised from last panel about the importance of entrepreneurship program in design schools. I met my co-founder for this at a class that's called Entrepreneurship in the Built Environment. And we were born out of a program called Design X, which was designed to turn the great ideas of architects and designers into ventures and business ideas, because there's just so many great ideas in different design studios and classes, and it will be a kind of a waste to let those ideas kind of slide away without the opportunity to try them to turn into operating ventures. So I just want to appreciate that. And about TangibleEmpact, just for context on what we do. So when you see an empty lot in a city, there's a lot of different opportunities. Some people might see a challenge. Some people might see investment opportunity. But when you think about what to actually build here, there goes the kind of the most expensive trial and error process in urban development. That's the pre-development phase. You have to think about the financial feasibilities. You have to think about the zoning, the architecture programs, the different feedback from communities. There's just a lot of data going on, and it's quite confusing. And those data live in different silos. It's really hard to have a holistic picture of what those data means and how those data affect your final decision. So the problem we're trying to solve in a way is living the pre-development. And this is where the most kind of crucial moments for an urban development, whether it lives or dies, but it runs down silo data right now. And there are different types of data, as we said, and the current process to kind of evaluate and consider those data are very inefficient. And there's so many back and forth going through all those different types of data to reach the final decision. And this really slows down the project execution. They add a lot of capacity and resources and cost to the project, and it limits the project's impact. And it's kind of crazy to think about, like in different process of the whole development, the most kind of consequential decisions are made with the least support from the current technology. We have so many different startups and ventures and softwares focusing on the design, the construction part, but on the early pre-development feasibility part, there's not really tools to support that. So that's kind of where we're trying to tackle. And I think that's always leading us back to those two important questions we're trying to answer, which is how can we better support the urban decision makers to evaluate a project holistically, not dimension by dimension, but across the full range of the constraint landscape. And furthermore, how can knowledge play a part in a process, that's not just shaped by the technical difficulties and complexity, but also by the institutional fragmentations and the competing interests. So that's what we're trying to solve. We're trying to build a AI-assisted decision-making infrastructure for new urban development. And we've been operating with different pilots. So the way we've been working, we're an early stage venture. We're not building a full product upfront. Rather, we're bringing our core ideas to different cities, different organizations, and customize the product to the specific project deliverables. So in a way, we are helping them solve a specific problem, but we are also learning from the whole pilot scope. And those pilots, the types run across different types of projects. They are affordable housing projects, rezoning projects, and mixed-use developments. And today I just want to share a lot of the pain points and issues that we observed from those pilots. I think the first kind of the core issue we've been saying is the silo data, as we mentioned. So we kind of expected in the beginning that the hardest part of pre-development is to be the analysis, right? The modeling, the calculation part, but it really isn't. The hardest part is to assemble the information that makes those analysis possible in the first place. So if you look at all the things you have to consider, right? The regulatory constraints, they live in different PDFs in different multiple municipality websites. The financial assumptions, they sit in different spreadsheets. The funding programs, they come from different Word documents in different federal agencies' website. The data, they all sit in a GIS system. So they're all incompatible in data formats, and they are kind of updating on their own individual timelines. And for every project to kind of construct this whole data landscape, it takes so much time and resource. And even so teams, like their primary job is just to monitor the city application portal for changes. Another core observation is the hidden trade-offs. In the early stages of an urban project, if you look at each metric individually, everything can check the boxes, but the tension really surfaces when you compare different metrics together and you evaluate them together, because a lot of the times the metrics are interdependent and they affect each other. So the current kind of evaluation process is not designed to surface those tensions and conflicts in the early stages. And when you find them later on, there has to be much more cost attached to it to reiterate and redesign the process. Another observation we have is the capacity gaps. So we really saw that the organizations, facing the greatest complexity and constraints have the least capacity to evaluate them. We're talking about small to mid-sized developers, mainly affordable housing developers, some under-resourced public agencies, and some emerging community organizations. They kind of operate under the tightest regulatory constraints, and they have the thinnest financial margins, but they hold the most complex and the biggest public accountability. But still, they rely on the same fragmented process, while bigger firms and bigger corporation developers can dedicate in-house teams or six-figure consulting fees to absorb and figure those conflicts. They simply just couldn't afford it. And we've learned that just putting together one light tech application for affordable housing development cost around $50,000. So the real consequences of this is capacity and agency. This really limits, which projects get to be built, where, and for whom. So to kind of respond to all those observations and challenges we've saw, here's kind of how we are approaching those challenges now and how we're designing our pilots architecturally and what we call an enhanced decision-making process. So the first step is data assembly. We have an AI layer that's actively monitoring and gathering the regulatory, the financial, the funding, and the spatial and policy data from different types and different sources and in different geographies. And they all flow kind of through this AI-powered extraction layer, where we have AI agents, constantly monitoring the data updates, parsing the data formats, and reconciling the conflicting different sources of the data, and structuring everything into a unified evaluation framework. And then within this evaluation framework, the user can build scenarios and test them against every constraint simultaneously, not separately and sequentially. So the scenario builder and the evaluation framework, they are connected in real time. So you can see all the impacts when your project changes. The third part is the decision support. Users can compare scenarios through detailed trade-off analysis. We have an AI reasoning layer that can surface which variables carry the most sensitivity. It can identify the actionable adjustments need to be made to your project and synthesize all the comparative logic kind of across the different scenarios. So when either a planner, a public developer, or a developer, a private developer, when they arrive at each decision point in the early process, they can have a cleaner understanding of what each path actually leads to and what the costs are. And so when we talk about scenarios, we kind of work across different scales. We can work within like a building scale to construct different programs within the building and mixed use building. All the way we can all work with multiple parcels and rezoning projects that has a large impact in the urban context. Yeah, I think essentially we are trying to change the way the early evaluation process is made in urban development and enable a cleaner and more comprehensive process for developers and planners to foresee the project outcomes and make better decisions and faster decisions in the beginning. So that's well like a brief introduction to tangible impact. The next thing I want to talk about is something that I've tried pedagogically this year. So, vibe coding really blew off in February, and I taught a class in January is trying to use vibe coding in GIS for designers. So for designers who have no coding background without any knowledge on, Python or whatever, how do we operate complex spatial analysis in GIS without learning the syntax? By the way, you can download this. This is a handbook with all the detailed information. You can download the PDF, vibe-coding.js.haozhuoyang.com, and you can download all the data used in this handbook. So essentially, I'm trying to ask this question, like, what if GIS became conversational? What if the spatial tools that has a higher technical barrier before can become sketchbooks for architects? We don't have to have the high learning curve to achieve all those technical capacities. And I think I think for the longest time, computation in design has been treated as a separate domain and a separate expertise. And you always have to refer to an external expert if you are just a designer trying to do something computationally. Otherwise, you have to spend like a week learning just the basic syntax to do that. But I think vibe coding is really come here to make a difference. And I think the current conversation surrounding AI and design has been centered around image creation, which is normal, like we're architects. But I think one part that's been kind of overlooked is the analytical aspects of how AI can enhance the designer's capacity to do much more things. So this is kind of like first endeavor to kind of pedagogically achieve that. So I taught like a short-term winter course at the Harvard GSD just on this topic. We had 3 sessions, and each session is an hour and a half. I had like 20 students without like coding background, but they kind of know JS somehow. And in the end, I think we had 30-minute session where everybody was kind of able to produce quite complex and quite interesting maps just by like vibe coding and asking the AI to generate the code into GIS and like operate within that. So to go deeper into the handbook, I think I was trying to change the mindset of, like I have to hire a developer or I have to learn Python to do certain things from I can just describe what I want, which is like a great skill set for architects. We have so many ideas on what we want, and I can just iterate until it works. So you just need to, understand what you actually want spatially. You just have to understand your own logics and your design intentions, and you can leave the technical part to be solved by AI. So, like before GIS is a pure analytical software. You are using it to do analysis. But I think from lowering the barrier and enabling architects to iterate very fast, JS can become an expressive tool where you can do a lot of cartography very fast and you can make strong design arguments within JS. That kind of transfer how JS is used by designers. And like from this traditional workflow of you have an idea, learning multiple steps of geoprocessing tools, figuring out, like which data plugs into where, which case should go where, which step, and you debug for hours. Now you can just have a vibe coding workflow where you can just fastly get the results and prototype a game to get better results. Just to give a sense of what's included in the handbook, so I provided like a basic data set in Manhattan about transportation, the zoning, the green spaces, the networks, and parcels and buildings. And in the first, and we have those kind of workshops documented step by step in the handbook, so you can really just open your JS and just follow along. And in the first part, I was trying to just automate a lot of basic GIS workflows with AI, so you can very fast, create buffers near transit stops. You can just select out different buildings that fit certain criterias, and you can do multiple calculations at once, very fast. Like you can do this under like 3 minutes, or even you can even be more creative and use GIS to create new geometries and create new shapes to emphasize your design ideas and your cartography language. So some things we tried in the course was, like what if we like shrink or expand the building based on its height? So it scales the building depending on the height, and we have like a height map of a plan of Manhattan. Or we can kind of draw lines between each building, each parcel into the nearest park, and visualize it depending on the density of the building. So we have kind of like a park accessibility visualizing a map of Manhattan, or even we can create new contours of Manhattan just based on the building height. So those are more kind of creative and expressive ways of using GIS just based on your design intentions. Yeah, so that's an effort that I made in terms of trying to incorporate AI into pedagogy and like exploring new ways to teach AI within design. Another thing I want to share is an organization that I started last year. It's called Harvard GSD Urban AI. I think the intention in the beginning was I've been to a lot of AI conferences, a lot of computational design conferences, but I think a lot of them are focusing on technical part, or they're inviting a certain group of people. But I feel like in the current climate, like there's just so many efforts that's done by so many different types of people in the term of urban AI. There are a lot of researchers, academia people, tech people, startup people, people in the government are looking into AI. But a lot of those efforts are siloed and not really trying to communicate with each other. So we're trying to create a platform that bring all those different types of people together and having a conversation about how do we collaboratively advance AI in the overall urban development process. And we are trying to, like tackle different aspects of this topic, whether that's from transportation, sustainability, AI, geospatial AI interfaces, or AI assisted engagement. So very quickly, we did the first conference last year in 2025. And you can see we have people from different schools. We have people from Google, from the city of Boston, and we have 3 discussion panels where one is focusing more on geospatial tools to advise policy. One about like different patterns of urban production, where if you are working as a computational designer at KPF, you're working with as a tech leader in the city of Boston, working as Google Earth leading Google Earth. How do you use different types of practices and production methods to tackle different challenges? And the third panel is about more on the city side, like how do the current city policy react to the AI innovation, and how do we have better frameworks to adapt AI innovations while being responsible? We just had our second conference this past year, this past 2 weeks ago. And this year, we're trying to approach this through scales. So we have 4 panels from human to building to neighborhood and to city systems. Still, we're really trying to mix up the panelists. So we have people from New York City, City of Boston, like a lot of design firms, KBF, SOM, ACOM, and we added a startup portion to it. So we invited like 7 startups to give demos before each panel, and we're trying to figure out, at each scale, how does AI impact different urban operations, and how do we kind of react to that from different professional lenses. Yeah, so that's kind of from a organization and an event type of effort that I was trying to make. So lastly, I want to share like a research project that I did with Perkins and Eastman 2 years ago. And so this is like a pure AI research project that we're looking into the topic of walkability, specifically walkability for older adults, and how can we design better urban environment for our older people to have a better experience of walking. And then what we approach this is that the current methods of measuring walkability is very top down. We have a lot of different proxies and different calculation methods to kind of calculate walkability, but they are not really from a human perspective. Like they are not really considering what do you actually see, what do you actually experience when you take a walk in the cities. And AI can make a difference to that. So we are trying to think this through an image perspective. Specifically, we're using the methods of object detection and image segmentation, whereas AI can detect, like what objects are in an image and how much portion of each object compose in the whole image. And if you combine that with a huge data set of Google Street View images, you can really quantify the whole urban landscape and the whole experience of people's working by understanding the exact elements within the urban environment. So we have that part to understand the cities. About the walkability, the site is in Hong Kong. So the Hong Kong government, the Department of Transportation, they do a very in-depth interview and survey on people's transportation pattern every decade. So this is kind of one of the largest data set on bottom up data about people's behavior of walking and their experiences of walking. I think there are like over like 100,000 responses in this data set. So we have those 2 data sets. And what we did was, so first of all, we calculated how likely are older adults to take a walk in different parcels in Hong Kong based on the survey data. So those data are coming from people's everyday experiences. So the darker the red in this map means that they are more likely to choose to take a walk. And we're using that as an indicator of the walkability in that neighborhood. And the other element is the urban environment. So we extracted like over 30,000 Google Street View images in Hong Kong. And really we're defining like 7 urban elements. So crosswalk, bench, wall, window, tree, sidewalk, and street light. And we're trying to understand, in each of those 30,000 images, how much percentages does each of those elements compose in that image? So we're using that as a quantifiable metric to understand, whether this area has a higher percentages of benches, that area has a higher percentages of windows, and using those as a proxy to understand what urban elements is playing what part in the whole neighborhood of Hong Kong. And the way we're doing that is just we're dividing the pixels of each urban environment in each image by the total pixel number of the whole image. So that gives us a kind of a map for each one of those elements. So the darker the blue here in the map means the higher percentages that you see for each of those urban element. And when you have those, walkability and the urban element percentages, what you can do is you can create, first of all, like an overlay visualization to see, like the base map here is the walkability, and the higher the volumes, the red volumes are the higher the urban element. So you can see the correlation between them. So some of those areas have really high walkability, and you can see a higher number of those urban elements, and some of them have lower. Some of them, even though they have higher walkability, they have a lower element. So you can really identify those different areas of different typologies of the correlation between them. And the next step we did was to create a. So we did that across all the 7 urban elements. And then next thing we did was to have like a quantitative analysis on the correlation between them. The first thing we did was just to create a very simple single linear regression between those two data sets. And then what we found out is that bench was the most kind of important element to walkability. That means the higher the bench, the more likely the neighborhood is to be more walkable. But the kind of the value the benchmark value for each of those stimulation is not that great because, as you understand, walkability is quite complex. So it's understandable that each of those elements, like individually, is not doing much to the walkability. But the next step we did was to have a multiple linear regression, and we paired 2 elements together, and we're looking at the paired effects of those elements, their impact on the walkability. And as you can see on this diagram, that the combination of the bench and the sidewalk has the strongest impact on walkability. So this really gives urban designers an idea on the importance of different urban elements and how we can design better urban conditions. And what we did then was to, like, okay, let's go and find, like in the actual images where bench and sidewalk has higher percentages. And then we take a look at the actual streets and actual urban environments and take a look at the AI segmented images. And we kind of concluded different kind of design guidelines that derived from this analysis to help urban designers to design better streets. So one of the guidelines is to have intervals of pedestrian respite, and you need to combine street furniture with greenery and open space. Another one is about the width and the height ratio of the street and the transparency and openness of the facade. Because you can see the wall and the window and the benches, they have a really high impact on the walkability. So we're trying to have this idea of like a facade intimacy and crafting the street dimensions to create better kind of relationship between the pedestrians and the urban facade. So in the end, this research is kind of contributing to different ways of looking at walkability, like apart from the normal walk scores and different top-down planning ways of looking at walkability. We're providing an alternative to look at it from the human experiences, from the actual street view images, to understand the walkability. So yeah, that's just the 4 kind of projects that I try to do for the past 2 years. And yeah, so looking forward to the questions and the feedback.
Thank you, Haozhuo, very much. This is fantastic. I'm going to launch us into the Q&A, and then we'll see where it goes with other questions. From my perspective as an urbanist, I'm really appreciative of how you brought us into how AI can inform urbanism and urban development and urban scale GIS. I remember learning GIS as a designer and struggling with it, and it's fun to see. It's great to see that there's ways that we can engage with it now that don't require as much sort of white knuckling and pulling out hair as I probably did. And one of the things that I had mentioned earlier is that here at the BAC, part of our strategic plan is really to bring in and develop an entrepreneurship and innovation institute that looks at the intersection with design. Urban design is also part of our strategic plan. And 4 years ago, we launched a pre-college urban development, urban design, and urban planning program, 6-week course in the summer, in partnership with the City of Boston, so that high schoolers, both residents of Boston as fellows and high schoolers from all over the country are working on Boston projects with the city of Boston to inform projects that are happening now. And from all parts of the projects, from the very beginning, where you were talking about the development part, the middle, and the end. And then we're also launching a master's degree in urban design this fall. What I am wondering, and you are teaching here, thank you. You are teaching here at the BAC. I'd love to hear more about the class you're teaching. I'm really interested in how what you are doing can inform our emerging areas and dance with it. But this is the thing, and this is maybe a question for everybody here. How do we think about that through the lens of an inconvenient education? And I think the previous two speakers, including President Doss, looked at the power of an inconvenient education here at the BAC. And so that's a question to you, Haozhuo, as well as to everyone in the room. So I will hand the mic back to you.
Yeah, thank you, Sarah. So I'm teaching the Art2 studio for undergrad, where we are designing a community kitchen in Mission Hill in Boston. And I think one of the most relevant thing that I observed is Mission Hill is quite complex neighborhood, right? Like on the urban scale, the relationship on demographics, on the traffic, on the environmental history is quite complex. So in my teaching, I spent like 2 weeks trying to push the students to come up with a more urban narrative and like design thesis to support their kitchen design. And in that process, the students had a lot of questions. Yeah, questions about the different types of people living there, like a lot of different questions about a lot of detailed aspects of different types of data. And I try to provide a lot of like resources to them. But I think one of the students spent like a week just to try to learn the GIS and try to answer his questions. I think because they are only second year undergrad, so I wasn't expecting them to have a very detailed quantitative analysis to support the design thesis. But I think the enthusiasm and all the questions they are asking can tremendously help their design much better if they can have way easier access to the technical solutions to answer their questions and do those analysis. So I think even it's an architecture studio, an early design studio, I think having that lens of quantitative analysis and like a lower technical barrier can really help their early design thesis and narrative. So I think that's something, yeah, I've been thinking about how can we kind of help the early stages of design education from an analytical perspective, not to turn everybody into, like data enthusiast or like a very data-driven approach, but to inform their own design thesis.
Great. And then this is one more question for maybe, it's really for us all to ponder. How do the idea of an inconvenient education is that we're shifting the ownership from the educator to the student, right? And so what are opportunities for that in this work? It's a question that you may have an answer to right now. We may all just want to chew on it and just floating that out there.
Mm.
It's a big question. And that's what the president brought to us this morning. And that's really what the BAC has been about. As a student myself with the Solar Decathlon, I learned what that felt like to go from being a consumer to being a producer to being able to own what was being produced in the project. So I'm just curious how that plays out with new technologies, disruptive technologies like AI, right? Other folks, yeah, do you have?
Yeah, I think one thing I would add is that I think right now the role of like design instructors, as you said, are shifting. But if you look at, as you said, from emerging technology lens, what needs to be taught, like it remains a big question. I think I think if you think about a lot of the technical skills and a lot of the technical aspects of design education, like that I think can be easily replaced or like hugely improved in efficiency. So what's the core design skill sets that we still need to remain, and like how are the order of those different education play out in the early design education program? Um, is a big question. Yeah.
Great way to frame it. Thank you. Questions from everyone who's joining us. Marilyn, you're on mute, just so you know.
Yeah. So the question I have is on the analysis and the walkability, which was really fascinating and wonderful that you have done it. And I'm wondering how much just the age has an impact on what makes something walkable. So if there was a children's playground at the other end of the park, you'd see a lot of middle-aged people. The bench, obviously, for the elderly is going to be the most important. And so how do you factor in or slice and dice the ages of the people who are there and what would make something walkable? And and the second part of that is um, in the areas where the majority of people might be elderly because there's a elderly housing project, how does that affect the numbers?
Yeah, great question. I think the first about the lens of age. So this study is exclusively only looking at older people. Like the walkability we have here are data from we cut out the survey, just the I think Hong Kong's definition of older people is above 65. But we have some like other improvisations, like where we see, like for example, this strip of urban fabric has the most walkable areas for older adults. When we shift the age limits, it's a completely different story. So if you compare the different age groups walkability with the actual urban elements, you can have another research question of, like maybe bench doesn't provide like any benefit to the middle age people's walkability, and how do you see the different combinations of urban elements cater to different age groups? So I think that's kind of the next step of this research trying to answer. And for the second question about I think it's about the housing for older people you mentioned.
Right,
So this is the
it would skew any type of information based on the fact that most of the people who live in the area are elderly, as opposed to it bringing the bench bringing in the elderly, but the elderly are already there.
right. Um, so I think that's within the data bias, but I think what is clear from the data metric we used is that the choices of trips that people take that we consider here is leisure, like voluntary trips. Like they're not trying to like go somewhere, like just they're trying to take a trip, and they're trying to take a trip by walking. So we're using that as a proxy within the neighborhood as the walkability, and we're kind of like grouping the data within each of those districts. So I mean, it's not 100% reflective of the pure, like, walking. Maybe some people travel elsewhere to, take a walk. But I think that's the kind of the best proxy we can find to reflect the voluntary walking choices made by people living in that neighborhood.
Well, one thing, and again, what I'm struggling with is my own relationship to AI, which is in using certain platforms, right? And then how that then translates into something like what you just showed us, right? Like, so much of AI is how you prompt and how you have that conversation, right? And almost the framework with which you're engaging. And so when I look at that, at this map, I'm just thinking about what does that look like and how do you test your own framework and questions. Does that make sense from a does that translate from the AI I know to what you're working with?
Yeah. I think the framework is literally changing like every 3 months. Like this study was done 2 years ago. And I think if I were to do it now, I think first of all, the models will be like vastly more advanced. And I think the accuracy of the analysis will be much more better. But there are just so many new startups and new tools to help us do this type of visualization. So this is done by me literally prompting in like a programming interfaces, like coding the diagrams. But I think right now they have different ways of doing this integrated into different, um, Adobe has a lot of different plugins. Rhino has a lot of plugins. So I think the framework are integrated into a lot of different current workflows, and especially about rendering. I think right now there are just a lot of visualization startups like helping architects to communicate visually with different types of clients. So I think the framework is constantly changing and adapting to our own designers' own workflows, which is like a good shift, I think, in the industry.
That's interesting. Are there other questions?
Hi. If I could jump in, Haozhuo, it's amazing to hear about your work, and we're so thrilled to have you teaching Studio 2. I was really curious about the way you were describing the AI tools as working well for fitting a niche for small scale developers and community organizations that really need this capacity. And I'm just curious to learn more about your partners and if you have, stories to share about what they're looking for, what their stories are. I would love to hear about that out of curiosity.
Great question.
Yeah, absolutely. So just to share like some concrete examples. So there's a mid-sized municipality that they need to do a form-based zoning code. And I think what they're doing now is that they're running fiscal projections in 10 different Excel sheets. And whenever something changes upstream about, unit mixes, or, we want to add some public spaces, or want to add more green spaces, the whole process had to be redone again. You have to run all those analysis again. And that takes time and a lot of resources. And that just, because the process is really iterative, like something unexpected always come up, or like new comments on your community needs always come up. And that whole iterative process is just really like troublesome and cost a lot of money. So what we're trying to provide is a technical solution where that process is automated and you don't have to wait the time curve. You can just see the changes instantly. All the changes you can make from different sources, you can import that into the system, and you can see the impacts change instantly and see the financial, fiscal, environmental changes to make better informed decisions on what to do next. So, like we're trying to identify those type of different workflows. So that's with the municipality. For the affordable housing developers, like they have to apply for like 5 to 6 different funding programs to make one project feasible. And different funding programs have different parameters and requests for different types of units. So when when you change the unit mix, you might be more eligible or beneficial to certain programs, but you might lose some other programs. And the kind of like that test fit process costs a lot of time and money, and they had to hire like external financial consultants, architects, like juggling through managing all those consultants. So a centralized technical solution to integrate all those data to let them kind of have the power and like the ease and the fast response to make those decisions can really help them shorten the time frame to make those projects feasible. And when you reduce the time, you really save them a lot of money and their capacity to build more. So maybe now they can take on 4 projects instead of 2. So like I think that's the core kind of issue of like the missing middle housing, is that the capability of small to mid-sized housing developers. They can only do that many projects at a time due to the capacity limits. And if we can lower the barrier, they have the initiatives to just build more houses.
Thank you, Jessica. That was a really fantastic question, and Haozhuo, I really appreciate your response to that. And I'm wondering, there's sort of like a democratization potential there, right? Of everything in that's in the built environment has such a high upfront cost, high costs in general, and then high upfront costs. And so it sounds like this is potentially a way of allowing organizations that are working for communities in the public good to be able to do more. And just as we think about real estate and development, who are the movers and the shakers, right? Who's able to inform that, and you're bringing us into a model that perhaps shifts that. AI may help shift that, or your particular research. So thank you for that. Thank you for this amazing presentation and really opening our minds to what AI can do at the urban scale across so many different aspects of the built environment.